Static analysis in Perl. So this is an extremely misleading title, and you will know why by the time we get through this. So those of you who don't know me, my name is Stevan Little. I've been programming Perl for about 15 years, give or take. Stevan at CPAN, that's my pause ID. It helps when you have a name with a really weird spelling. You get it first. Stevan Little is Twitter. Nothing really useful on there, though. GitHub.com/Stevan. Also, again, nice to have his misspelled name. That's where most of my stuff is. These days, I'm a principal developer at Booking.com, but actually my job, that's my title, my job is the senior team lead of the tooling track in the core infrastructure department. So that basically means I handle all the miscellaneous crap. A little bit of history here. The Booking motto back in the day, Liz, correct me if I'm wrong, was hack and don't look back. Never phrased it like that, but that's what it was. And this is basically development optimized for business growth. You may think that this is a bad thing, you know. I know I did and still kind of do sometimes. But thanks to all the hard work of all the people at Booking.com who did all that, and all those people who came before me, it actually worked. And I mean, like, really worked. No, really, really worked, okay? We're a very, very successful company, and a lot of that is due to the fact that we did focus on the business development and not necessarily on the code early on. Of course, there were consequences. So, technical debt? Debt is kind of not really strong enough word. Technical mortgage is maybe a better way to put this. But you know, we're doing this in America here, so let's actually talk about it for real. This was a technical jumbo mortgage, or for the Dutchies in the group, Yumbo. That's an inside joke, sorry. So fast forward then to 2015. And I know it's 2016, I'm not that stupid, but this happened in 2015. We decided to pivot, just slightly, towards quality and craftsmanship. We've been relying for a long time on people like Liz, on people like Eve Orton, Rafael Garcia Suarez, and a whole crew of other people to basically do the right thing and build it well. But they weren't necessarily the only people writing code. So we needed to really sort of change the culture from that hack and don't look back to something that was a little bit more focused on quality and craftsmanship and long term. Basically, we needed to pay down the principal on that Yumbo mortgage. So in true Booking fashion, they didn't assign this to anybody. They didn't do anything about it. It was just sort of an idea they put out there, and they wanted us all to sort of take it and run with it, which is basically it's out in the open. Anybody who wanted to pick it up. They may ultimately regret this decision, not actually putting anyone in charge. Quickly, disclaimer here. When I submitted this talk, I thought we'd be a little bit further ahead in this project, but circumstances being what they are, we didn't really get that far. So a lot of what I'm going to tell you today is the ideas that we have, sort of the philosophy that we're trying to approach it from, and then some of the tools and things that we're going to do. So this is sort of part one of a talk. If you want to see really the results, come to YAPC next year, or the other option is to come work for us at Booking.com. And if you want to know the details about that picture, ask Sawyer. So, end of the disclaimer. So, all right, we're done with history. Now we need to talk about static analysis. First, we need to actually define static analysis. So this is what Wikipedia says. Static program analysis is an analysis of computer software that is performed without actually executing programs. Skip the parentheses. In most cases, the analysis is performed on some version of the source code, and in other cases, some form of the object code. That's a nice definition, but it actually really doesn't capture what it is that we want to try and do. Analyze, first, isn't really the best way to describe what we want to do. We actually want to understand our code. And the reason we want to understand it is because there's reasons. There's always reasons. One of the things, we do some Perl beginner trainings, because we actually don't hire many Perl programmers these days. We hire C++ and C# and Java and anything else. Anybody who will come to Amsterdam, essentially. But we teach them Perl. And we also teach them MySQL, because sometimes they're in Postgres or something like that. And in the MySQL training, one of the things that and in the Perl newbie training, one of the things I like to say is everything you thought you knew doesn't apply anymore. We have a different scale. We think about different things. And so it's important to understand why these decisions like this are made. Sometimes it's historical reasons. Some of our code really smells of mod Perl. You can see it in there. We actually have an Apache namespace. We haven't used Apache in years. But this is all historical, and you have to understand that. If you're going to try and affect and improve code, you have to understand why it has become the way it is. So we don't necessarily want to analyze it, we want to understand it. And static is also not really a good way to describe this. We don't want to just look at code at one point in time. We actually, one of the constants of the universe is change, and one of the constants of booking is always change. So no code really changes, or no code remains untouched for a very long period of time. So it's important for us to be able to look at this code as a living entity and watch it grow and change over time, and also to analyze the growth and change over the previous time. So I'm going to do a little quick digression here. On the plane here, I've been reading Neil Stephenson's new book, Seven is or something like that. Anybody read it here? A couple people? Okay. So it's got a lot of really cool stuff about like spaceships and satellites and orbital mechanics and all that stuff like that. How many people here know about orbital mechanics? Good. Y'all can correct me when I fuck this up at the end. One of the things that I find fascinating about this and the idea, and it sort of struck a nerve because it helped me understand sort of the way I'm trying to approach this problem, is that, just a tiny little nudge can affect a huge amount of change. You might have to wait for the change. You might have to go around the Earth a couple times, but you can readjust your orbit by, thousands of kilometers if you want. And also, it uses large spinning balls of mud to do things, which thankfully at Booking we have a very large ball of mud that we can do this with. Liz. So, I make this joke, but it's one of the things is that we really have to do is we have to be careful about the way we change. So these days, like I said, I'm the core infra tooling department. And we actually have we did a little exploration to try and figure out what the purpose of our track is. And a track is sort of a collection of teams, just a bit of a glossary there. And we decided that it was increasing developer productivity while reducing risk, which is great for me to be able to tell my bosses, because I can say it really quick and we're done. But the real thing that I would like to do is actually to affect long-lasting and meaningful change in this code base. And so that is actually sort of the subtext there. We can help people to go faster, but we need to make it better as well. But we also need to be careful about this, because it's not just my job on the line, it's the job of 14,000 people or something like that work for Booking in total. About 1,200 in the IT department, and we're growing. So if we screw this up and the whole thing falls down, we're in big trouble. We also need to be smart about the way we approach this. And by being smart, I mean knowing how dumb we are and really being humble in the approach to this. Again, understanding the history behind all this stuff. So we have to be very careful. And we have to take a long-term view, a really long-term view on this. Some of these little nudges that we might be doing may take months, they may take years to really see fruition. And most of all, we have to be willing to fail. We have to be willing to screw up. We have to be able to miss our exit velocity or escape velocity and just keep falling back down and keep getting back up and trying again. And basically what we want to do is we want to keep asking the what, when, and the how, which are what changes should we make? When should we make those changes? Now is not always the right time. And how should we make those changes? Sometimes the obvious solution is not the best solution. Sometimes you have to really think about this and you have to figure out how can we test these things? How can we measure them? And measurement is very important because that's your metric for success. And we basically just need to keep repeating that until everything is awesome. Now, we have these questions. Where are our answers? For that, we need data. Quite unfortunately, we don't have any. And when I say we don't have any, I mean when I started asking people, how many lines of code do you think we have? I got answers anywhere from 500,000 to 10 million to whatever. And I wasn't even asking about all of our lines of code. I was just asking about the lib directory in our main Git repository. And nobody knew. Some people got close, but nobody actually knew. Just for the record, it's about 3.5 million lines of code. That includes comments and documentation. And if you take those out, you're about 2.5 million. So that's actually not a bad ratio of comments and documentation, although some of that may be just long commented out code. I don't know. I haven't found that yet. But, but the thing is, we really didn't know. So that's where we actually had decided we had to start. And this is kind of ironic because booking loves data. We love to monitor things. We love to pull data out of everywhere, but apparently not our code. And I'm sure people tried to do it over the years, but nobody kept it, nobody sustained it, and nobody continued it along. And that's an important thing. You have to continue to do this. You can't just stop, analyze, fix, and start again. You have to have a continuous operation on this. So effectively, we were blind. And so the story that I'm going to tell you now is all the tools that we're beginning to explore and we're beginning to think about as the methods to remove this blindness and to reveal to us what we have there and then hopefully begin to answer some of those questions. So that's it. Now we're going to delve into some of the details. These slides were made like 5 minutes ago, so they don't have a lot in there, so I'm going to talk a lot more. So I apologize in advance. So the tooling track is made up of a bunch of topics. And among those topics is the packaging team. This is actually the team that's run by SawyerX. And they have a couple of different things that they're doing. The first thing is we're actually trying to figure out how to get dependencies under control. We have something like 2,000, 3,000 dependencies. I don't think anybody even knows that. I don't know that. And they're kind of a mess. They're all in this weird RPM naming convention structure, kind of weird. It's a mess. We decided CPAN, that's a great way to organize code. That's a great, if we have a local CPAN, we have, so anybody remember that whole little thing with NPM and the whole like break everybody's build stuff? Okay. We don't want to be subject to that. We also want to have a control of our dependencies. We want to be able to sort of vet new versions and run them through. So we set up a local CPAN. I think we actually have a mirror, maybe, I don't know. Yeah, we have a real mirror, but we actually set up an internal one that's completely on our own. And that was very, like I said, very specifically to have a good control over our dependencies and what flows in and what we end up using. And of course, if you have a CPAN instance, why not also set up a meta CPAN instance? We have like a perl.booking.com or something like that is, it's just I think, pod to HTML, run over all of our dependencies and all of our code and stuff like that. But if you've ever looked at pod to HTML output, it's just kind of, it's not that interesting. Meta CPAN, on the other hand, has a ton of information. You go to any page in Meta CPAN, you see a ton of information, all of which would be valuable for anyone at Booking looking to add an additional dependency. The other nice part about Meta CPAN is the API, which is basically just a proxy against Elasticsearch. And we can add stuff to that. So we're beginning to work on adding things like, is the author of this module a Booking employee? If they are, then we definitely don't trust that code. No. Are they a Booking author? Do we actually use this as a dependency? What server role, because we segment our different servers in different roles, what server role is this a dependency on? So all this other meta information, and there's tons of it out there, I'm just giving you a few examples, we can actually just shove into Meta CPAN. And we're not even forking Meta CPAN to do that. We just put it into Elasticsearch, and because the API is pretty thin wrapper around it, we can get it all out very easily, which we can then use for Pakket, which is Dutch for package. And this is a project that Sawyer's working on, which is essentially, well, I guess it's your reinvention of packaging as a thing, but it's from a different point of view. We wanted to be able to control the way we build and serve our dependencies. The previous way was to use RPMs, and each module was packaged as an individual RPM. And we had things like when you restart your machine on dev, it'll install any new modules that need to be updated and stuff like that. But it was really just a large mass of goo, and it was really difficult to really know what was going on. Many times I would see new modules just appear, and they wouldn't be ones that I would have chosen. So we have no real control over that. Pakket, we hope, will give us that control, and in particular, the build step of Pakket. If you want to know more about that, maybe Sawyer will give a lightning talk.
Probably not.
Probably not. Okay. Either way, if you want to know more about that, you can talk to Sawyer. But the idea there is that we wanted to actually have a lot of control over the way we do this. We don't want to have to always, I think Gene Hack said in his talk, don't use system Perl, and we don't use system Perl, but we install a Perl into the system and then we install a bunch of dependencies in that. So really, how much better is that? It's still all managed by the system. We wanted to have more control over this. So that's what Packet does. Next is static analysis. So sort of what the talk was originally supposed to be entirely about, but it's not. This is something that's it's a bit of a dark art with Perl, because when you think about Perl code, meaning what will be executed, and then think about Perl source. How much difference do you think there is between the two of those? Okay, the source on disk is only a small percentage of what actually gets inflated and becomes code within the interpreter. So knowing that, we know that there's a limit to how much we can actually do with static analysis, because I'll be damned if I'm going to try and write a fake Perl interpreter to analyze stuff and do all that kind of stuff. That's crazy. Perl is just an insane machine, and I don't want to go there. But we can get a lot out of the patterns of the source, because ultimately that's what we humans actually deal with, and that's the thing that probably the change will be most meaningful to humans. So we have a couple different things on this. We have, and I'm going to slow down a little bit because I think I'm going too fast. We've been running Perl Critic over time. So what we did, and Vicenti, is he in here? No, okay. All right, so one of the guys in our team, Vicenti, he is around, and he gave a talk about Rust and Perl and stuff like that. He did a thing where he basically pulled all of the Git history into Hadoop, and then ran analysis over every single checkout, various bits of analysis, both Perl Critic runs, as well as just source code size, subroutine size, package size. What was the other? McCabe complexity scores, like all sorts of various software metrics, and he just ran it over the entire 500,000 Git commits, then linearized them in a reasonably close facsimile to actual time, and then we graphed them. Unfortunately, there wasn't too much that we were able to find in there because we actually didn't know quite what we wanted to look for, but there were some interesting things. Like, for instance, we could look at the growth of a subroutine, and then we could look when it got refactored, and then we could look at the growth of 2 subroutines, and then we could look at them, and so on and so forth. We also graphed in errors and warnings because we actually track those in our monitoring really, really extensively, and we actually basically track those errors and warnings. So you could see sometimes the errors and warnings filling up that space beneath the growth of the growth curve of the code. Not always, though. Sometimes the code got really big and the errors and warnings went down. Things like that. That's data that we don't know why it is, but we need to start digging in and start looking. So we've been sort of weeding through that to see what we can get out of that. Additionally, we have an engineering guide. So one of the things that did come out of the quality and craftsmanship announcement was an engineering guide. And the engineering guide, in also true booking fashion, is very vague and leaves a lot to the authors, or to the developers, to figure out what they want to do. There were, however, some sort of very specific things about Perl. Please don't do this, please do that, please avoid these constructs, please avoid that. So it's a perfect case for Perl Critic. So again, this is also Vicenti's work. We wrote what we're calling Be Critical, which is a collection of Perl Critic policies that are reflective of our engineering guide. Additionally, with that, we've also been collecting some base Perl Critic policies that also we know basically fit in with that idea. And the hope, too, is to build on that more and more as we begin to find some of these problems over time. And also, too, this will probably get released open source, so if you guys want to follow it, you can. Along with that, because one of the things about running Perl Critic over booking code is that there is a lot of noise. Well, violations. Call them noise, whatever you want. And it's very, very difficult to tell people, hey, you should follow this Perl Critic policy. You should fix your code here. Before you commit, please run it against these policies. And then you see 2,000 violations. You don't know which one's yours, which one's whatever. So again, Vicenti wrote something called Patch Critic. What do you like about it?
Oh, I think git blame is the best thing in the universe.
Okay.
So this is like git blame Perl critic.
Exactly, exactly. That's a perfect way to describe it. When you commit something, he will do his best to figure out if you introduced a new violation within your change, or if you just introduced a new violation, because sometimes that new violation will show up, 6,000 lines below where you actually made the change. But it will attempt to cut through all the noise to give you the right signal to prevent you from making that change before you actually start committing it. So this is actually a very, very neat tool. We're going to be refining this one soon and probably putting it out on CPAN as well. And I highly recommend, if you do any sort of Perl Critic code review, test this thing out, because I think it could be very useful. Additionally, at Booking, we have people with spare cycles. Every organization will have people. Liz. Every organization will you'll have some idle time. I've got an hour before the next meeting. I can't actually sit down and write code and do anything. I could just go through emails, watch a YouTube video, whatever. I could just waste an hour, or, and this is something that hasn't been released yet, I'm working on it right now, it's up on GitHub, or you can fix some violations. So what this will be is a way to basically start a session on a code base and record all the files that you want to critique. Then you can begin to just pick up where you left off and start going through and fixing them one at a time. You make a fix, you stop, you commit it, you could push later, you can push now, it doesn't matter, it's up to you, but you build a series of commits just fixing issues. The day before I left to come here, I think it was like 75 commits, all of just doing one single Perl Critic policy, which was unused variables. Unused variables are really hard to track down. And Perl Critic doesn't do a perfect job at it, but you combine that with a human just doing some search and replace in the editor, and you can get them. 75 unused variables just gone. And it just took me a couple hours of just screwing around waiting for a meeting to come while I was just basically testing my app. This is a good way to this is death by 1,000 cuts, or improvement by 1,000 cuts. So each little one, and if I can get 5 people doing this, and we're committing 50 commits every couple of days, we're going to wipe all these violations out in not too long. And it's also a little fun. I put some coloring in it and stuff like that. It's kind of neat. There's a cow that tells you when you're done and all this kind of stuff like that. So maybe I'll have the little ASCII duck or something on there. So anyway, but the idea here is, you want to be able to use the computer to help you look at your code and then use your own spare cycles to improve it. We're also doing dynamic analysis because, like I said, the difference between the code that's actually in the interpreter and ready to run and the difference between the source that's on disk is very different. How many of you saw Gonzalo's talk about Devel Quick Cover the other day? Okay, I highly recommend you all watch it on YouTube. It's a very, very cool tool. And since not many people saw it, I'm going to repeat some of the stuff that you said. So what Devel Quick, how many of you are familiar with Devel Cover? Okay, everybody, good. So Devel Cover, as we all know, is a coverage tool. It tells you how many times each line of code was executed, if each line was executed, et cetera, et cetera, et cetera. We don't actually care how many times you executed the line of code because we get millions of hits. These numbers are unimportant. We just care if you did. So what Devel Quick Cover does is essentially hook into the opcode that is represented by a semicolon, so statement terminator, essentially. And it hooks into that, and the first time it sees that you've run the code, it makes a mark, and then it replaces itself with the original opcode. So the overhead on this is just about nothing. You can run this in production on every single one of your boxes, and with the exception of the fact that it takes about another 100 megabytes, 100 megabytes of memory, which, by the way, is pretty cheap. Hold on. Yeah, I got a quarter. So 100 megabytes is pretty cheap, and so you can run this on all your machines and then know, is this code run? Is this code not run? Because that's actually a really hard question to answer. And we won't actually be able to answer it, wait, I should get to the side. We won't actually be able to answer it fully because some code gets run every, 6 months, 8 months, once a year, okay? We won't know about that stuff, but we will be able to get a good picture of it. and throw that in with some other data, and maybe we can actually get a better, an actual accurate picture of it. We also, I recently added a patch too that it actually measures which, or it marks which compile phase things were running, because one of the things that we found when we first ran this data is, wow, every file is used, because it all compiles. Use strict, use warnings, those lines are done, those lines are executed. But they're actually unimportant lines to us. So anything that's in begin time we know is done in our preload, and anything that's in runtime is stuff we have to care about. That's code that we actually know that's running. And it does produce some reports. We're working on improving some of the reports. We might augment them a little bit with some PPI analysis, stuff like that. And also one of the tricky problems of this too is code changes. So coverage information about code doesn't really go between changes. So we do have an aggregation tool that will attempt to find the longest continuous run of no changes in a file and aggregate everything up for that. So it'll go from one git tag to another git tag. Is that one released? So that's out?
That's not released.
Okay, that's not released, but yeah, we're using it internally, but that'll eventually get released out into the wild as well. You know, and maybe, and I'm not really sure, this is a big maybe we can actually do that stuff across git tags. Maybe we can actually break this down to a level of just per subroutine. If the subroutine hasn't changed, we can probably just use that information there. It require a little bit of guessing and stuff like that, which might decrease the confidence in it, but you know, hey, what do you do? Again, these are decision augmentation tools, not decision-making tools. These are ways to get you information. So we're also doing that with our HTML template compiler, which, funnily enough, is a fork of HTML template. Yay! Who uses that anymore? But actually, it's a totally different, it looks like HTML template, but it's a totally rewritten thing. It's fast as all get out. And it pre-compiles a lot of stuff like that. So we actually, somebody went and wrote a coverage tool for that. And fortunately for that one, if it gets compiled, we're almost certainly using it. Or I'm sorry, wait. Yeah, if it gets compiled, we're almost certainly using it. If it doesn't get compiled, we're not. So it's a little bit easier. There's a little bit less trickiness in this one, but it's very, very valuable information. And I believe he managed to figure out and then get rid of like 40% of the templates in the first run. They were just there. They just hadn't been cleaned up. You know, people just hadn't gotten around to it. So these tools, though, help you get rid of code, because the best kind of code writing is when you delete. Okay, and the less code you have, the more you have to understand as well. So the two of those really work for that. In addition, we also have something called Devel Stat Profiler, which I recommend you all take a look at. It's a statistical profiler, so it's a sampling profiler. So it just you can run this also in production, but it just grabs information over time and attempts to aggregate and merge it all together. I have to admit, I don't really know a whole heck of a lot about this, but I'm sure you could ask any other booking people, they might know on that. But that's also important, because you do want to be able to profile your code, and you want to be able to profile your code in production. So, and I am running very fast on this, so I'm going to slow down. Tooling. How many of you have worked in a language that isn't Perl that had some really nice tooling with it? Yep. Don't you miss it? I'm not even a big Microsoft fan, but I love Visual Studio, and I love ReSharper, and I love just taking the mental vacation of writing code with ReSharper and Visual Studio and ASP.NET. I don't have to think, I just do it the Microsoft way. But even that aside, the tooling support is huge. We as humans can only keep so much in our head. So like inline documentation, autocompletes, you know, all this kind of stuff is really hugely helpful, and it can really, really increase the velocity. And Perl has shitty support for this, really shitty support for this. There are a few tools out there. There's IntelliJ, which is very, very nice, but you have to run Eclipse. There are Vim plugins and stuff like that as well, but then you have to run Vim. And then there's Emacs stuff, because Emacs is an operating system, and why not have everything in there? So, but then you have to run Emacs. Now, we don't dictate which editor is used. So we've been looking into a number of tools that have been appearing lately that attempt to abstract this. So there's a few tools out there. One's called SourceLib, SRClib, which last I checked didn't actually build, so who knows. Another one called, I think, Kite or Kike or something like that, which basically is the same thing. And what these things propose to do is they provide plugins for all your popular editors. Emacs, Vim, Atom, Sublime Text, TextMate, you name it, whatever. What, Nano, Pico, yeah. Ed said, like, cat, yep. Cat's awesome, dude. So, butterflies? Okay. Okay. So we've been exploring these tools, and basically what you do is you extract all your information out of your Perl code by analyzing it, stuff it into basic JSON files and stuff like that on disk, and then these plugins take over. Now, we could have tried to enforce editors or something like that and write one plugin for this, and everybody must use Eclipse, and everybody's using IntelliJ, but that just doesn't fly with how we work at Booking. So we're exploring these other ideas. And, you know, it works quite well because it's just basically extracting a bunch of stuff from Perl code, which we can even use in other places as well. We've also been giving a look into web IDEs and actually sort of playing with one on our own at work. Web IDs, you know, they seem kind of silly and childish, but there's some of them that are actually getting quite advanced. And by web IDs, I don't mean it's always in a browser. For instance, Nucleide. How many of you know about Nucleide? Anybody? We got one person. Okay, so Nucleide is like Facebook's IDE, because apparently you can't check out their mono repo before the heat death of the universe. So they basically created this remote IDE. It's all written in Node, whatever. But it basically allows you to have a bunch of stuff on the server and your client locally, and it just communicates back and forth. It's also highly pluggable and completely open source. So we're beginning to explore that because, you know, maybe we could standardize on something, but maybe we could. I don't know. We'll see. But tools like that are very, very interesting. And especially for Booking, because we do have a rather large repository. We also have, nobody develops on their laptop because nobody has terabytes of room for the databases. But people, so we have a KVM infrastructure, and that's how we work off of that. Well, if you could run a Nucleide server on your KVM and a client on your machine, on your laptop, that might be an interesting setup. But only if it supported Perl, of course, because right now it all really supports is JavaScript and PHP and Hack or whatever that Facebook thing is. So anyway, we're beginning to look into a lot of these things because tooling is actually a very, very important thing. And especially, we have so few Perl programmers anymore. And they all come from a land of nice tools. And they all want nice tools. And they're all just sort of clapping together whatever they can to get there. So we want to really boost up the support of that. We're also looking at tools like GitLab. I'm not entirely sure this is going to work out. We've been traditionally against code review, except for our PCI stuff because we have to do it there. But a lot of people are asking about it. So tools for that. And this is one of those things, it's like code review tools, some are good, some are bad. A lot of them want to enforce workflow, stuff like that. GitLab doesn't do that. So that's why we're sort of leaning in that direction, and we're exploring that. And this is all comes down to repository organization, which is also something that's really, really critical. We have a mono repo, which means we have, well, we don't have a mono repo. We have 420 repos, but one is the big one. And that one big one, basically, there's a lib directory in it, and it's got a bunch of code under there. This makes it very hard to discover code. You know, it's that 3.5 million lines of code. It's very hard to discover the code in there. It's very hard to understand what these things are. We also have a lot of non-English speakers whose naming conventions sometimes are good, sometimes are bad, sometimes are completely horrible. So they're not necessarily, and I'm no good at coming up with names. Like Moose, what the fuck is that? So like, but this is important. Discoverability is super important, and organizing a repo in a sensible way can make a huge amount of difference. This is one of those gentle nudges that I see. If we can just gently nudge the shape of that repository, we can build a better tomorrow that'll happen years and years and years from now, but hopefully we can guide them towards a better tomorrow. We also have a really interesting tool. How many of you used code.google.com back in the day before it was gone? Okay. So they open sourced the search component of that. I don't know if you all know that. And I think it's just a Go daemon at this point. And you can point it at all your repositories. It indexes the crap out of them. And then you get a Google-like interface that basically allows you to just search. And it'll find, so it's like git grep, but across 420 repositories. Okay, it's huge, it's useful. Actually, I don't know if we have all 420 in there, but anyway, it's really, really useful. Right now, it's just a standalone thing. We intend to actually connect it with some of the other stuff, and we're going to do that with a module that I've been working on as well called source tooling, which is basically just a random collection of tools to extract data out of Perl code and extract data out of Git related to Perl code, turn it into JSON structures, and either give you command line tools to pipe that stuff back and forth, or a web service that will connect it. It's very, very raw these days, but if you want to take a look and are interested in it, it's up on GitHub. And finally, all of this comes together in something that we're going to call code.booking.com, which is going to be the internal portal, the internal enterprise portal to all our code needs. And this seems simple and stupidly simple, but you know what? This will probably be one of the most important parts of this well, my prediction is the most important part, because everything will be in one place and it'll be organized, and you will never be more than like 1 or 2 clicks away from all these tools and all this information. Okay? And that's one of the things. We grew as a company so organically, so quickly. Sorry. We grew as a company so quickly and so organically that we didn't have time to step back and make sure that all this kind of stuff was organized. I mean, we had a wiki, but yeah, we had a wiki. You know what that means. And it's Confluence as well, so yeah, John, yeah, it's bad. So, I'm sorry, Liz, am I causing too many? Is this like post-traumatic stress or something? So you know, nobody had time to organize this stuff. So that's going to be one of our main goals, because discoverability of what you have and the tools that are available is the most important thing about tools. Because if people don't know they're there, they're not going to use them. So it's a really, really simple idea. So anyway, that is sort of the overview of the tools. Because Booking did pay for me to come here, I do have to pull some recruitment here. So, if you find anything that I've said in the last 40 minutes interesting at all, you can help. Like I said, every single thing that we're going to do is going to be open sourced. Over my dead body, we will keep it inside. I want this all out. I want this open source because it's going to benefit you guys, and also you guys can maybe help us. So you can contribute open source, but it's a lot more fun. You get a little sailor hat like that. Okay, this is at our annual party. We fly in about 8,500 people from across the globe, and we have a 1 week sort of conference, et cetera, et cetera. But the fun part is that there's a huge party at the end of it. Really a lot of fun. So yes, come explore with us at booking.com. So, questions? Chris? Because it was the best one I could find. Okay, questions?
So if you had like a perfect PPI, a perfect parser, what would you use to build your perfect IDE? Like how would you analyze Perl and build your perfect IDE?
So you asked if we had a perfect PPI, and by asking that question, I assume you mean PPI kind of sucks. Which it does. PPI, in my opinion, has one major deficiency. It builds this nice little model for you, and when it runs into a complicated expression, it gives you a list of tokens. And you have no idea what's the right-hand side, what's the left-hand side of this expression. It gets very messy. So PPI has a few deficiencies. We actually, sort of on a bet, sort of on a challenge, one of the guys in my team wrote a Perl parser in TypeScript, which, by the way, is a very nice language. I recommend everybody take a look at it. But he ran into the same problem, figuring out all that stuff. But actually, I wouldn't use it in an editor. I would use it for semantic patching. This is one of the things that Google does with some of their C++ code. They basically rewrite essentially the AST, the abstract syntax tree, and then write their changes. This allows them to do massive across-the-board API changes very, very easily. I would love to have that for Perl. Without a good PPI and without a good parser, probably not going to have that, but who knows? That may end up being what we do. But yeah, if I could, it would be doing semantic patching, because then I could actually fix all those Perl critic policies in one flow. So, but anyway, man in the back.
You mentioned a new packaging system, and one of the reasons you gave was that in the old one, or the current one, I should say, packages are showing up by surprise. Now, that seems more like an organizational problem than a technical one. Why would changing the packaging system help you?
So it's not so much that they were showing up by surprise. You know, you had to actually commit into basically a giant YAML file that I don't believe is actually proper YAML.
It's some parsers of YAML.
Right. It's valid for some YAML parsers. It's a big giant YAML file, and you just basically add your dependency in there, and the RPM packaging team is actually the team in Singapore. So it works out quite well. You submit a ticket at the end of the day. You come in the next morning, and usually Joel has packaged it, and you have an RPM, and then it'll just install. And one of the ideas was when you continue to restart your machine during development, we want to keep you as up to date as possible. So we will install new versions that when you get that new YAML file with your the latest git pull, it will install things for you if necessary. There is a certain element of people problem. Yes, I totally agree. It's very difficult for even any of us to choose what is a good CPAN module. We have our personal preferences, we have our personal biases, et cetera, et cetera, et cetera. It's tricky. So we want to be able to enforce that a little bit more and have a little bit more control over that, and also control over changes and new versions. We have some modules that are really old because people haven't cared about them for 3 years, and so they haven't been updated. And then they get updated, and it just all hell breaks loose. So we want to have that under control, and just the simplistic way that we had right now doesn't give us that. We also wanted to be able to do pinning versions, all this kind of stuff, which we have tools like Pinto and Carton for, but we need to do it sort of from a different angle. Talk to this man. He will give you more details on it. I'm totally not doing it justice. Yes. Yes.
So your comments about moving from a time of rapid growth to a time of consolidation and better quality really, that really resonated with me, and I would like to hear more about challenges of changing the culture you speak about now.
So that's like a full talk, but I will summarize it by saying the easiest way to do that is to hire a bunch of people who are not Perl hackers and make them into Perl hackers, and then you can do whatever you want because you can define the whole culture as you go. Liz, how many people were at Booking when you started?
35.
35 people. Okay, and is that the entire company or just the IT department? That was the entire company. We have 14,000 people in the company now. We have 1,200 people in the IT department, and I believe the projection that I last saw is that by the end of the year we want to have 1,500. We approximately 25 people a month we onboard, and this is designers, front-end developers, data scientists, and Perl developers, but there's at least, what was it, Sawyer, like 10 Perl developers a month at least? Give or take. We're working on training programs, stuff like that. So it's less about how do we change this culture, it's actually how do we preserve it in the face of all this change. And all these people coming in from Java, from C# and all this place like that. So we kind of don't have to worry about it because it's going to happen inevitably, and we just want to, again, it's that guiding, that gentle guidance. So I'll get behind you first, and then I'll get to you, Jim. Sorry. Yes, so source lib that I mentioned before is sort of the underlying component apparently for source graph. And if you don't know what source graph is, I do highly recommend taking a look at it. It's very cool. One of our Go devs at Booking is friends with the guys who are doing source dev, so we've been looking into it for a while, but they don't have Perl support. Now, we may actually end up adding that for them and using it, but the tool is a little on the rough side at this point. It's very nice for Go. It's not so great for everything else yet. But yeah, it has a lot of potential. Yep. Jim.
What parts of the problems that you were describing in this talk would be mitigated or mitigatable if you were to be writing in Perl 6 instead of Perl 5?
I don't know if it would mitigate anything. I would make it worse, maybe. No, I'm kidding. So, I had to, Liz. I'm getting the side eye here. No, I think Perl 6, I mean, we'd have an AST. Actually, you know, funny story. The better PPI, my best hope on that is not that TypeScript parser that this guy wrote, but Perl 6. Because Perl 6 has V5, it has STD5. Like, I got a Perl 5 grammar written by Larry. If I can make that work, then I can get a lot of good stuff out of it. They're both a bit rotted, unfortunately, but I'd rather fix a bit rotted thing than write the whole thing myself. So we may ultimately use Perl 6 to analyze and improve Perl 5. Go figure. But yeah, if the code was in Perl 6, I really don't know. Perl 6 is too young. I really couldn't guess. So, anything else? Yes.
You said you were starting to do more peer reviews, or has that not started?
So all right. PCI stuff, we had to do it. Finance stuff, we had to do it because money. And actually, Brad here wrote a tool called Git :code :review, which is a command line tool that does that. It's very cool. I've been digging into it lately. I highly recommend checking it out. But people just want to do it. As an organization, we don't enforce it. As an organization, we don't enforce anything. We expect our developers to be smart and find the tools that make sense for them. But there has been a lot of questions about, hey, can we have a code review tool? Hey, can we have a code review tool? And one of the really crappy parts of being the tooling track is that we have these monthly hackathons, and people do all this cool stuff, and then on like the Monday afterwards, I get a little jabber message, hey man, can you maintain this? It's like, I don't want your crap, no! Those things sometimes can be very productive, and GitLab is one of the ones that came out of that. So like people want these tools. We can either let just random cowboys in the middle of 700 devs pick a thing, and then you don't want to depend on something that you didn't plan and that you're not going to be taken care of. So we're starting to look at this simply to stem the tide of that. But code review it's an optional thing. If a team chooses to do it, they can. If individuals choose to do it, our Android devs do it a lot simply because the senior dev on that team is in Slovakia and everybody else is in Amsterdam, and they've got time difference and other stuff like that. So, but yeah, code review is sort of it's a good thing sometimes, it's a bad thing sometimes. They get to choose whatever they want. So, anybody else? Anything? No? Oh, Jeffrey?
There's been an announcement to make an announcement that the silent auction ends.
Uh-oh. Silent auction ends at noon. 10 minutes. Okay.
So, when he finishes,
All right.
don't rush out yet.
Do we have any more questions? No? Okay. John, this one's for you. I told Laura we were going to use those, so I had to. You're welcome. All right, that's it.